Hi class, in this recording we will be focusing on PhysioEx exercise number 5, activity number 4, which is going to look at the effect of blood pressure on the flow rate of blood. So those are the two variables we'll be analyzing in this particular activity. As you work through the activity, you're given some background information and some instructions, and then a chart to fill in. That chart that you fill in your lab manual focuses on the two key things you want to focus on, the flow rate and the blood pressure. The chart given in the simulation gives you a bunch of extra variables. Radius is unchanging, viscosity is unchanging, and the length is unchanging. We only care about the pressure and the flow rate. As pressure increases, flow rate increases. And as we graph this, the line goes up in a straight fashion. It's a positive linear slope to describe the shape of this graph. As we look at our master equation dictating this, we find, wrong button there, let's clear and go back up to the top. Delta P here represents change in blood pressure. So as the change in the difference in blood pressures increases, the flow rate will also increase. So this is a direct relationship. And as we plot it, we had that positive linear slope. Again, make sure you memorize that equation. And activity number 4. Let's look at our questions, our review questions for activity number 4. So how does increasing the driving pressure affect the flow rate? As the pressure goes up, the flow rate goes up, based on our data. Question number 2. Is the relationship between blood pressure and blood flow rate directly proportional or inversely proportional? And why? It is, to answer that question, it is directly proportional. When one goes up, the other goes up. As we look at question number 3, how does the cardiovascular system increase pressure? Our cardiovascular system, or our heart and blood vessels, can increase blood pressure by increasing the contractile force of the heart. So the left ventricle of the heart can squeeze with more force, or we can make it so that our blood vessels are smaller. We can have vasoconstriction. And both of those are variables that we can control rather quickly over the course of seconds to increase blood pressure. Question number 4. Although changing blood pressure can be used to alter the flow rate, this approach causes problems if it continues indefinitely. Why is it bad to have constantly modified blood pressures? And the answer to that is that it can throw off our fluid balances in our body. If we have elevated blood pressure, we have excess fluid leaving the bloodstream. If we have depreciated or lowered blood pressure, we're going to not have enough fluid exchange with our bloodstream. We need to have a relatively constant blood pressure. Another issue with changing blood pressures is that it can influence the amount of blood going to the brain. If we have low blood pressure, oftentimes we don't have enough blood going to the brain, and the individual that has the low blood pressure will pass out frequently. If somebody has has high blood pressure for an excessive period of time, that excessively high blood pressure for a very long time can cause blood capillaries to burst. Sensitive blood capillaries, for example in the kidney, the glomeruli within the nephrons of the kidneys, oftentimes will burst, and that individual will start to urinate out blood. So as we want to regulate our rate of blood flow, fluctuating blood pressure a little bit for a short period of time is a good mechanism, but it's not a good long-term approach towards regulating our blood pressure. That's all we have for activity number 4 of exercise number 5. If you have any questions or comments, please feel free to post them in the class discussion boards. Happy studies.